Welcome to Unit 1, or Chapter 1, Section 7. This is the last video in Unit 1, so it's the last video in the introduction chapter. And we're going to go over inverse functions. So an inverse function is something that is, you can think of it as reversing what the function did, so undoing it in a way. So an inverse function is something where you take the inputs of one function and they now become the outputs of another function. So notice there's a couple of things that we are going to have to say about inverse functions. They're one-to-one, which means you don't share any y's. Notice the notation is f of -1 of x, and it is not equal to 1 divided by x. That's not what it means. I know if we were to use exponents, a to the -1 would be 1 over a, but this is in function notation. So it's not the same thing as this. Because this would be y to the -1. So that would be your value y to the -1. This is the inverse. So we can think of it as, the example your book uses is temperature. So if you have Celsius and you want to get to Fahrenheit, that process of changing that equation over to get Fahrenheit is finding the inverse. And that's an example from your book. So I will leave it there. And we will, where are we in the definition? All right. This can also be written as f of -1 of f of x equals x. And it also follows that f of the inverse of x equals x. And this will be true if the inverse is f of -1. So what that says in maybe different notation, -1 f, this is what it says. And according to the other one, this is also true. So do you remember how last time when we were talking about composition of functions, we had g of f was not equal to f of g? Well, here that actually means something. So what that means now, if we have g of f equal to f of g, then f and g are inverses of each other. So that means g equals f of -1, or you could say f equals g of -1. It'll be one of those. And it's read, you don't say f to the -1, you say f inverse of x. F inverse of x. This is how you would say it. Also keep in mind, not all functions have inverses. So remember, to have an inverse, you have to have a one-to-one function. Not all functions are one-to-one. Okay, so we're going to verify that two functions are inverses of each other. So if for a particular one-to-one function, notice it has to be one-to-one, f of 2 equals 4 and f of 5 equals 12. Well, if f of 2 equals 4, then we know that the inputs of that function are going to be the outputs of our inverse, and the outputs of our original function are the inputs of our inverse. So this is the answer for f of 2 and for f of 5 equals 12, then f inverse of 12 equals 5. So what this says is, if I had my function f of x, and I had 1, 2, 3, 4, and this was 7, 8, 9, 10. This is my table. Well, then my x for the f inverse is just going to be switched. So I'm going to have x and then f inverse. Now my inputs are going to be my f of x's. And my outputs are going to be my original x's. So this is the original, and this is the inverse of the original. So it flippy floppies. Okay, testing inverse relationships algebraically. So f of x is 1 over x squared. G of x is 1 over x minus 2. And remember that no matter how we compose them, if we put our original first or our inverse first, we're going to get x. So if g equals f of inverse, and I don't know, let's say I want to use this one, then this one is g of f of x, because remember g is the f inverse. So then I'm going to take g of 1 over x plus 2, which is equal to 1 over, and I'm going to put 1 over x plus 2 everywhere I have x. Now remember, if I have a fraction on the bottom, I just flip it to bring it up. So that becomes x plus 2 over 1, but I'm not going to say over 1 because it's kind of understood everything is over 1, minus the 2. Oh, and we can see if we were to drop the parentheses, we would just get x. Now let's try the other way around, f of g. Well, g is 1 over x minus 2. So we have 1 over x minus 2 plus 2. Remember, because it's everything where x is gets replaced with g of x. And that gives us 1 over x, because these cancel out. And once again, we have a fraction as a denominator, so we flip it. So it looks like they're both equal to x, so they are inverses. So g is the inverse of f, or f inverse, whichever you want to say. So determining inverse relationships for power functions. This is a good one. So determine the inverse relationship. Remember, f of negative 1 of f of x equals x. And even if you switch them, they should still equal x if they are inverses of each other, only if they are inverses of each other. So we'll start with g of f of x like we did in our last problem, since g is the inverse. So that's going to be g of x3. X cubed. And that's going to be 1 over 3 times x cubed. And that's going to equal x cubed over 3. Is that equal to x? No, absolutely not equal to x. That is not equal to x at all. They don't look similar. So, therefore, we don't have to go any further because we know it's not an inverse. Yeah, we don't need to go any further. Not in inverse. Finding the domain and range of inverse functions. I'm going to go ahead and call it here because this next one is going to involve all of our toolkit functions. So that sums it up for 1.7, Inverse Functions, Video 1, and I will see you in the next one.